What is WebAssembly? Let's get into the core concepts, get into a definition, and really from top to bottom talk about why WebAssembly exists and how you can actually get started with it. So first up here, we have what is WebAssembly. It's a low-level binary instruction format for a stack-based virtual machine. It's also designed as a compilation target for high-level languages. And you can also do things like enable deployment of client server applications and also have near native performance execution capability. So the speed is a huge component of why WebAssembly is pretty exciting. From a technical architecture standpoint, it implements a binary format with deterministic execution models. Also, it has a representation of a control flow with validation constraints, and it has a linear memory model with protected execution, and it also utilizes static type as well so that you can build really safe functions. So the runtime characteristics are that it is able to be executed in a structured stack machine environment, and you can process structured control flow like blocks and loops and branches, and you can operate within memory safe sandboxed execution environments, and you can also leverage static validation to have a consistent behavior as well. In terms of how would you compile down to this, it will accept lots of high-level language inputs, C++, C, Rust, and it also is able to implement very efficient compilation strategies. And it can generate optimized binary format output, and also you can debug it through source maps. So in terms of the architecture, this really gets you into three components. We have the virtual machine, and in this case, this is the WebAssembly that operates within the browser alongside the other JavaScript, and it allows you to have two distinct code execution pathways while maintaining seamless interoperability between both runtimes. You also have a binary format. In this case, the WebAssembly is using a compact binary format that's been designed for low latency and near native execution, and the instruction sequences are optimized for modern processor architectures. In terms of the memory model, this linear memory model through an array buffer allows you to have low-level memory access while still maintaining the security of the browser sandbox environment. So in terms of the core technical components here, we have the module system, and this functions as a fundamental compilation unit. We also have the stateless design for cross-context sharing, also explicit import and export interface mechanisms, deterministic initialization semantics. And in terms of memory management, talked about this previously, but it exposes this resizable array buffer for linear memory operations, and also has bound checked memory access, direct manipulation of binary data, and also it maintains memory isolation between different instances. So if you deploy multiple WebAssembly components, each one is isolated. And then in terms of the table architecture, this is storing reference types that are not represented as raw bytes, and also it implements dynamic dispatch and supports function reference management, and also enables indirect call operations. So how would you integrate with WebAssembly? We have C++ development pathway. This would be using things like EM scripting, Toolchain, also implement LLVM backends, generate necessary JavaScript interface code, and also provide the DOM access through the JavaScript bindings. For Rust development, which is what I'm more interested in, this leverages the native WebAssembly target support, and it also implements WASM bindgen for JavaScript interrupt, and it also provides a direct WebAssembly pack integration and also zero cost abstraction. So there's a really good story for Rust development with WebAssembly. And then we also have assembly script, and this is a TypeScript type development environment, and it implements strict typing requirements. It provides direct WebAssembly compilation and also maintains familiar tooling capabilities. So in terms of performance, the execution efficiency is that it's getting near native execution speed. It implements optimized instruction sequences. It reduces parsing and compilation overhead, and also maintains a consistent performance profile. In terms of the memory efficiency, because it's able to have direct memory manipulation, it has a very efficient memory story. It also reduces garbage collection overhead and optimizes binary data operations, and also has a very predictable memory pattern. Now let's talk about two other things here. Security first. In terms of security, because it works in a sandbox, you can enforce the browser security policies, memory isolation, same origin restrictions, and also control external access. Although you can actually toggle that and call out if you need to. And then in terms of web platform integration, we've got the JavaScript interopts, which is bidirectional functional calls, and also primitive data type exchange and structured data marshalling, and also synchronous operation. And then DOM integration, this is where you can access the DOM through the JavaScript bindings. You can implement event handling mechanisms, support web API, and also maintain browser compatibility. Really, to wrap things up here, we have development toolchain, and with the development toolchain, there are compilation targets, so you can support multiple source languages. You can have a optimization pipeline, debugging capabilities. You can have tooling integrations. And so the development workflow would be, you would support a modular development pattern, implement testing frameworks, performance tools, profiling tools, and also maintain a deployment optimization. So in terms of future developments for WebAssembly, some of the things would be garbage collection, direct DOM access, more integration there, also better debugging, expanded language support, better platform evolution, etc. You can find out a little bit more about WebAssembly if you go to developer.mozilla.org. There's a good page here that talks about the WebAssembly concepts. What is the spec? You can also look through the different functionality, including the web APIs, and also look at some of the future things. So that's probably the first place I would take a look at. And there's also official curriculum as well from Mozilla.